Okay, in this video, we'll be looking at graph plotting, and here we'll be talking about a graph that is a bit complicated compared to the previous one we did. So this is graph plotting 2. So now again, I have my graph paper, as you can see here. I have my graph paper. Then I also have my table of values. Now the table of values here, I'll do a little bit of explanation here on it. Now this is actually a graph to determine acceleration due to gravity, and you're using a meter rule. LP is the various positions on the meter rule. So first you're going to start with 5, you carry out oscillations. The number of oscillations you're carrying out for this experiment is 10 oscillations. Okay, so you carry out oscillations, you record the time, and you go again, record the carry out the experiment again at position 5 or length 5, record the time for 10 oscillations like that, and then you do it 3 times and you take the average. That's this plus this plus this divided by 3. That will give you 16.19. When you're done with that, you calculate the period. Period is the time divided by number of oscillations. So you work with the average time for each period. Alright, so the average time divided by the number of oscillations, which is 10. So this divided by 10, we write our answer. This divided by 10, we write our answer. This divided by 10, we write our answer. Alright, so that's it. That's how you get the period. Then here we have L equals Lg minus Lp. Now in this experiment, the first thing you'll be required to measure is the position of the meter rule, alright, at the center of gravity, or the position of the center of gravity. So how do you go about that? You simply place the meter rule on the knife edge, and at the point where the meter rule balances without tilting to either direction is what we call the position of the center of gravity. So you record that down. Now in this experiment, or for this table of values, 50 cm was taken as the position of the center of gravity. So we have Lg minus LP. So our Lg here is 50. So minus 5. So say 50 minus 5, that will give you 45. That's how they got 5 here. 50 minus 10, that will give you 40. 50 minus 15, 35. 50 minus 30, 20, and so on. Now, the next one is t squared. You come to your period, you square it, you write it down. You come to period, you square it, you write it down here. Come to this period, you square it, you write it down there. So that is the column for t squared. Now L squared, you come here, you square the values you have there. This is L squared, everything. That will give you L squared. Now here they say LT squared. So you come to L column, multiply by t squared, write it down. Come to this, multiply by t squared, you write it down. Come to this, multiply by t squared, you write it down, and so on. Now in this experiment, you're required to plot a graph of LT squared against L squared. You're plotting a graph of LT squared against L squared. So since it's a graph of LT squared against L squared, it simply means LT squared will be on the vertical, and then L squared will be on the horizontal. It's a graph of LT squared against L squared. So LT squared will be on our vertical and L squared will be on our horizontal. So now we've already drawn our axis, the vertical axis and the horizontal axis. Now the next thing to do here will be to label the axis. So come down here, we'll label our axis. So this axis is for LT squared. And what is the unit? The unit for this is centimeter second squared. Right? And then against L squared. Alright, so we label our axis LT squared against L squared. So we label our horizontal axis being L squared. The unit is centimeter squared. Alright, so we have LT squared against L squared. LT squared against L squared. Alright, now the next thing we do here is to title our graph. So we have title, which is a graph of LT squared in centimeter second squared against L squared, which is in centimeter squared. So this is going to be the title of our graph. Now the next one here is our scale. So how do we go about getting our scale? Now the same method we've used previously in graph 1 of um, the same method we use in graph plotting 1. You see the same method we are going to use here. What is the method? We use the principle of interval, that's to get the value we'll be increasing by, then we calculate our scale. Now, what's the principle of interval? We say interval will be equal to the highest value, alright, minus the least, divided by the number of grid lines we're using to plot. So let's get the interval for LT square axis first. Alright. So say LT square axis. Let's get the interval for LT square axis. So our interval here will be equal to, now what's the highest value for LT square axis? The highest value we have from our table of values is 117.9, and then the least is 36.5. So say 117.9 minus 36.5 divided by the number of grid lines. That's the thick lines we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is 10. Alright, so say divided by 10. And that will give you, so that will give us 8.14. So this is like our lower interval. So to get the upper interval, you multiply the lower interval by 2. So that will give us 8.14 multiplied by 2, and that will give you 16.28. Alright, so our interval will fall between 8.14 to 16.28. Alright, so now we need to choose a number here. A number between 8.14 and 16.28 that will be very easy for us to work with, and it should be a number that is easily divisible by 5. So after 8.14, or let's look at just whole numbers. So after 8, the next number is 9. The next number is 10. 10 is easily divisible by 5 and it's not a bad number. So we can go with 10. Alright? So now we say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Alright? Now we have 100 here, but whereas our highest value here is 117.9. So we are not able to cover all the values here. The highest value is 117.9, but our graph can only get 200. So what do we do here? Now in this case, for graphs like this, our advice you make use of what we call a squiggle. Squiggle. Alright. Squiggle is just zigzag line we indicate. Alright. We use it on the axis, and then it's used to indicate that there are some missing points in that axis. So we are going to use squiggle here, and then we are going to start from the value closest to the first plotted point, or the least value there. All right, we're going to start from a number that is closer or very close to the first plotted point, or the least possible number on that table of values, which is here in this case 36.5. This is the least number. So we can start around 30, all right, or maybe 35, or maybe 20. All right, so in this case I'll start with 30. 30 is very close to 36.5, so I'll use a squiggle, and then my first point here is going to be 30, and then I'll have 40, and then I'll have 50, 60, 70, 80, 90, 100, 120. So you see it was able to cover everything now, all right, with the aid of a squiggle. Okay, in this case now, there's only starting with 10, my first interval, or the interval, the scale of this graph. Don't point saying 10, 20, 30. No, I use a squiggle, and then I start with 30, but the same interval, 40, 50, 60, 70, 80, and the likes. All right, so the squiggle there is just to indicate that some points or some regions here are missing on this graph. That's the essence of a squiggle. So we are going to use it right away, and then we input our values. All right, so this is what we have. So let's start with the first value. I said I'm going to start with 30 in this case. So I start with 30. Now the next number, based on my principle of interval or the scale I calculated, I have 40 to be next, and then the next one will be 50, and then I have the next number here to be 60, then I have 70, then this is 80, this is 90, this is 100, this is 110, then I'm going to have 120 in this region here. Okay, so this is what we have here. I have 120 here, this is 120. Okay, so my graph, I do not have enough space here, so that's why I had to bring the unit here. Please, your unit is very important. Always attach it on your axis. So this is what we have here. So the scale for the vertical, you can see here for each 1 cm or for each big box, we are increasing by 10. So say 1 cm. So say scale, say 1 cm represents 10. What's the scale? The unit on the vertical axis, we have 10 cm second squared. 10 cm second square on LT squared axis. So this is our scale for LT square axis. Now the next one now will be to get the scale for L square axis. So still use the same principle of interval to calculate it. Alright, so using the principle of interval, here we have interval to be highest minus least divided by number of grid lines. That's our formula. So go again to our table of values. Now this is we want to get scale for L squared axis. L squared axis. We want to get scale for the horizontal. So our interval, let's try to calculate it. The interval will be equal to, now what's your highest value here? 2025, 2025, and then this is 100. So the least is 100. So we have 2025 minus 100 divided by the number of grid lines. Now, how many grid lines do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So divide this by 14. Alright, and that will give us our interval. So calculating this, we are going to get 2025 minus 100 divided by 14. So that will give us 137.5. So we have 137.5. So this is our lower interval. So to get the upper interval, we'll multiply our value here by 2, our lower interval by 2. So that will give us times 2. So we have 275. So we need a number between 137.5 to 275. That will be very easy to work with. A number that I prefer, a number divisible by 5. Alright, so here we have 137.5 to 275. So let's just work with whole numbers. 137, 138, 139, 140. A very good number we can work with here is very close to this, or above 137.5, moving towards 275. The first number we can have there is 150. So 150 is a very good number. So we can work with 150. Alright, so let's see. Trying this, we have, this is going to be 150, 300, 450, 600, 750, 900, 1050, 1200, 1350, 1500, 1650, 1800, 1950, 2100. So this was able to cover everything. Our highest value here is 2025, and we have 2100 here, so we are good to go. So there's no point using this our zigzag line here. All right, the squiggle, there's no point using it here because we are not omitting anything, omitting any points. All right, we are starting with 150, which is actually within the first plotted point. All right, and we'll be increasing by that 150 interval. But here the first plotted point was supposed to be 10. All right, or the first point of this axis was supposed to be 10, but we used this, all right, squiggle, and then we started with 30 just to indicate that something was omitted. So here nothing was omitted. Our interval is 150 and we're starting with 150. Here it was 10, but we started with 30. That's why we use this. All right, so we have, we write it down. This is going to be, we have 150, this is 300, this is 450, and then this is 600, this is 750, and then this is 900, then this is 1050, this is 1200, this is going to be 1350, then this will be 1500, this is going to be 1650, then this is 1800, this is 1950, then this is going to be 1950, then this is going to be 2100. All right, so this is what we have now. We've gotten our scale for the L square axis. So for the L square axis, we say 1 cm represents, this is going to be 150 cm squared. 150 cm squared on L squared axis. So we can go ahead now to plot our graph. Alright, so this is the title of our graph and the scale. The graph is a graph of LT squared, the unit cm second squared, against L squared, the unit cm squared. So we have this against this. And then the scale, we have 1 cm represents 10 cm second squared, alright? 10 cm second squared for the vertical on LT square axis, which is the vertical. So we're increasing by 10 cm second squared. So now the next one here is for the horizontal. 1 cm represents 150 cm. This is supposed to be cm squared rather. All right, so that's the unit we have here on the horizontal axis. Sorry, on L square axis. This is supposed to be L square axis because the graph of LT squared against L squared. All right, so this is what we have. So now it is time to plot our points. Now the first plotted point, you remember we are plotting LT squared. All right, we are plotting this. We are plotting LT squared against L squared. All right, LT squared against L squared. That's these last two columns. So then let's start with LT squared. When we have 117.9, we have 2025. 117.9 and 2025. So 117.9 will fall between 110 and 120. All right. Now remember I said you're supposed to have 4 thin lines in your actual graph paper, which will give you 5 boxes in between within a big box. All right. But let's assume it's 5 here. Though what we have here is 4. But let's assume it's 5. So we'll divide by 5. So we have 120, 110 to 120. All right. From 110 to 120, our interval here is 10. So each thin line here, we say 10 divided by 5, that will give us 2. All right. So this is like saying 112 and so on and so forth. So 120 now is what we have here. We want to get 117.9. 117.9 is approximately 118, 118. All right. So this is 120. So approximately 118 is what we are looking for. So we can choose this point here. All right, 118. And then on the horizontal we have 2025. All right, now 2025 will be between 1950 and 2100. And remember, our interval for the horizontal is 150. So if we should add 150 to this, we get this. Now what's going to be the value of each small line? Again, assume we have 5 small boxes inside, so we divide by 5. So we are going to divide 150 by 5, and that will give us 30. Now we want to get 2025. Now if you add 30 to 1950, that will give you 1980. So this is 1980. You add 30 to this again, plus 30 plus 1980, that should give you 1980 plus 30, that should give you 2010. All right, and if you add 30 again, that will give you 2040. All right, so here is 1980, 210, 240. So what we are looking for is 225. It should be between this, okay, between this point here. So we trace it upward, we trace it up, and then it should be around this region. Okay, it's in between this. So this is around here. This is what we have, and then we are going to mark it with 118. So we can take this to be our point. All right, so let's choose here as our point. So that's what we have there. Now the next one is 160, 1600 and 100. Now 100 can easily be gotten here. You can see we have 100 here. Now the next one we need is 1600. So how do we get 1600? 1600 should be between 15 and 1650. All right. So now remember, a value of each small thin line here is 30. All right, because we divide 150, which is the interval, by 30 by 5. So to get 1600, let's subtract 30 from this. So we have 1650 minus 30. That will give you 1620. All right, so this is 1620. You subtract 30 again minus 30. This is 1590. So the next line here is 1590, which is actually close to 1600. So we can say 1600 should be around there. All right, so trace it upward again to 100. So this is where we have 100. So I plot this point here now. All right, now the next one is 1225 and then 79.8. 1225 and 79.8. So this is 1200. Let's see 1225. To get 1225, we add 30 to this. So that will give us 1 to 30 actually. So 1225 should be between 1 2 and 1 to 30. So it should be around this region. Then we have 79.8, which is approximately 80. So we can just take it to be 80. Okay, so we choose here. So plot our points here. Okay, so this is what we have here. Now the next one here is 450. 450. So let's see. This is 450. Okay. this is 450. All right, now 400 should be between 300 and 450. So if this 450 subtract 30, this is going to be 420. Subtract 30 again, we're going to have 390. We should be between so that means 400 will be between 390 and 420. Okay, so let's just put it in within this region, and then we trace it to meet 50. So this is 50. 50 can easily be gotten, so we can mark this point. All right, so this is what we have. Now the next one is 225 and 40.35. So 225 should be between 150 and 300. Between 150 and 300. So how do we locate 225? Okay, we add 30 here. This is going to give us 180. If you should add another 30, so this is 180. If you should add 30 to this, you're going to have 210. All right. And then if you should add 30 again, that will give you around if you add 30 again, that should give you around 240. All right. So 225 should be between 240 and 210. So we can just make somewhere around there. Somewhere around there, and then we have 40. So we can trace it 40.35. 40.35 is not exactly 40. Now remember here you're increasing, the interval is 10, so to get the value of each small one, divide by 5. So this is going to be 42. All right, 44. So 40.35. 40.35 basically is actually approximately 40, so there's no need for that, so we can just choose somewhere around there. Okay, now this may not be a really very perfect graph, but you can use this principle on a graph paper where you have 5 smaller boxes and you get it very perfect, very accurately. All right, the reason why this may not really be perfect or very much accurate is because we have 4 small boxes here and I'm using 5. All right, the reason I'm using 5 is because in the actual graph paper it's supposed to be 5, but that's the most common one. Okay, so let's just go ahead with it. So here we have 136.5. So this is 30. 36.5 is approximately, should be around 36 or 37. So this is 30, we have 32, 34. So you can just use somewhere around there, 32, 34. Just take somewhere around there as our 36.5, or let's see this region here as our 36.5. And then we have that with 100. So this is 150. You fall down, that will give you 120, and then we have 90. So you can say it's around this region. So you can just mark this. All right, so let's just go with it this way. So now it is time for us to get a line of best fit. All right, so this is going to be my line of best fit for this graph. Okay, so you can see it fits perfectly for it. It's just close to all the points and it was able to take some points as well along. So this is my line of best fit. Now to calculate the slope, you just go to watch the video on slope, the same principle we use, change in vertical over change in horizontal, and then you get the unit. So our unit for this slope here is going to be we have cm second squared divided by cm squared. So our unit, this is supposed to be cm squared, please. This is supposed to be cm squared, please. All right, so we have cm second squared divided by cm squared. So our unit is supposed to be per cm second squared. The unit for this slope here will be per cm second squared. So use the principle for calculating slope. I'll drop the video link in the description. Use it to calculate the slope for this graph and drop your answer in the comment section.